All right, good morning, everybody. Let's do this. So, lesson 9. Before you actually go through it, let's actually just review a little bit of what we did yesterday. The game plan today is students represent addition and subtraction and conjugation of complex numbers geometrically on the complex plane. So, we'll explain what that means very soon. But just to review from yesterday, that if I have some complex conjugate, like let's say if this is z is equal to a plus bi, what was the symbol that shows complex conjugate? It's just z bar, and that's equal to a minus bi, right? This is the complex conjugate. And the modulus, what was the symbol for that? It looked like that absolute value, and that's just equal to the square root of a squared plus b squared, right? Because we use the Pythagorean theorem to kind of show this little thing here. Okie dokie. So let's go to the next part. Here, what does each concept represent geometrically on the complex plane? Like if I have z is equal to 3 plus 4i, then z bar is the complex conjugate, so it's just 3 minus 4i. So let's say if I were to put those 2 points here, if this is 3 plus 4i is where? Boom, here. This is 3 plus 4i. And 3 minus 4i would be 3, boom, right here, and that's 3 minus 4i, right? And here, what is the geometric interpretation of it? Pause the video and try and answer this first question. Describe the geometric effect of taking the complex conjugate, okay? What's happening geometrically here? And if you want to see the solution, here it is. It's a reflection across the x-axis. So if I have some point here, it's just reflecting over this x-axis, right? Or if I have a point here, how can it's being reflected over here, right? If I wanted to take the modulus, let's see here, if I have z is equal to 3 plus 4i, and I take the modulus of z, this is equal to the square root of, remember, this is my a, this is my b, right? So I'm just taking a squared, so it's 3 squared, and always put parentheses, plus b squared, so that's my 4 squared, and so z bar is equal to, well, 3 squared is 9, plus 16, so z bar, I'm sorry, not z bar, the modulus of z is square root of 25, and that's equal to 5. But here, what is the geometric representation of taking the modulus? Let's try and answer that question by yourself. What does this value mean, the 5, on the complex plane? Like if this is 3 plus 4i, what would the modulus represent, right? Describe the geometric effect of evaluating the modulus. You are taking the distance from a point on the complex plane to the origin. So here, this is the point. We are taking the distance from this point to the origin. And the origin is, boom, right here. So this distance from here to here is 5. Okay? That's the geometric interpretation. Let's also review this concept of we talked about before. What is the... Let's take a look at this. This question here, my bad, there we go. Okay, here, describe the geometric effect of multiplying a complex number by I. So here, imagine if we're 2, right? What happens when you do 2 times I? We showed it before, there is this 90-degree rotation, right? And then now here, if I'm 2, you see now I go from 2 to 2i. If I do 2i times I, where do I go? Now I'm at minus 2. And then I could just keep doing this, right? This is 90-degree rotation every time we multiply by I. Okay? So the question I have for you, which will actually get to the lesson, is here, I showed you here that if you take the complex conjugate, it's a reflection across the x-axis. This is taking the distance. Multiplying by I does a 90-degree rotation. So the question I have is, and we're going to answer this as a class. If I have 3 plus 2i, right? Let's say I'm 3 plus 2i, I'm over here. How can I reflect, not across the x, but how can I reflect across the y-axis here? Okay, what operation can I do to this 3 plus 2i to somehow get to the other side, right? How would that be? Where would the reflection be? It would be where? It would be negative 3 plus 2i. So then what can we do to actually do this? Okay, so try and think about that and we'll answer that as a class. All right. One stuff I want you to think about as we go through the lesson is, how can we shift a complex number left and right or horizontally on the complex plane? So if I have 3 plus 2i, so this is my 3 plus 2i, how can I make this point go left? How can I make it go right? How can I make it go up? How can I make it go down? What's the operation that we do to it to make that happen? Okay? And what I'd like you to do is go through these examples in your book together or by yourself, and you are going to see the geometric interpretation of some complex arithmetic that's happening in this in these problems, okay? And then try and go through this. And here, questions 5 and questions 3 will help guide you through this, okay? And together, I'll make another video and I'll show you the last part, and this will be a very nice question to do. Okay, have fun.